Hello everybody, welcome back. The purpose of this video is to begin chapter 7. We'd like to do section 7.1 and section 7.2. 7.1 is highly theoretical. 7.2 we'll actually be doing some work. But the chapter is called sampling distributions. And it's the theory behind all the of sampling distributions is, for example, we've talked several times. We're polling, we're doing some kind of survey in which we want to survey. Suppose we want to survey 30,000 people. 30,000 people. Well, one erroneous thinking that we've had so far is that it's one poll of 30,000. That's not the way it works. In statistics, that's not what we do. We just don't do one poll of 30,000 people. Rather, we'll do maybe 300 polls of 100 people, or maybe 600 polls of 50 people, and that's how sampling statistics works. And so that's what a sampling distribution is. In reality, that's what we're doing. And in order to continue with this, there's a theorem. It's theoretical. It's a theorem. Central limit theorem, it's called. And essentially what the central limit theorem says is if you have a sampling distribution where you get bigger and bigger and bigger size samples, just say 30, I guess. If you have a population, so there's a population, and it has a mean known and a standard deviation known. What we're saying is that we can have, if we have a sampling distribution, and you get at least, you get at least 30, where n is greater than or equal to 30, at least. If you have that, then the sampling distribution will resemble the population, the sample distribution will emulate the population. Will be an approximation of the population. And the bigger the better. There's 3 parts. N is greater than or equal to 30. The bigger, the closer. The bigger n, the closer it gets to actually what a normal curve. I guess it's over. Normal distribution. The more it is, and then there's 2 other parts. Instead of using mu, population mean, we're going to use something called the sampling distribution mean. This will come from all the samples, and for all intents and purposes, those 2 are going to be equal. The only difference is because we're taking a sample of n, the standard deviation of population of the sampling population is going to be the standard deviation of the population divided by the square root of n. That's the difference right there. It's theoretical, and that's the first section. Virtually nothing problematic. I mean, there's really no problems in the first section. I just want to read. Well, all right then. Suppose you're given a population. We know this is a population mean. This is established, historical. The mean is 85. And the standard deviation is 9, and then and then we take a sample of 100 of these, And all we're saying is, what is the mean of the sampling distribution? It's the same as the mean. It's 85. What is the standard deviation of the sampling distribution? It's 9/10. 9 divided by the square root of 100.9. And that's the first section. Right, sir. So now what's going to happen in section 7.2 is we're actually doing sampling distributions for, we're going to be talking about the means of these sampling distributions. And section 7.2, it's all because of the, all because of the central limit theorem. We're going to do just normal problems, normal curve problems. Because of the central limit theorem, the problems will be just like section 6.3, like 6.3, normal distributions, except the sample distribution, that's nothing different. The sample distribution standard deviation is different. So Z is going to be, I'm going to put Z, oh, I screwed this board up. I'm going to put Z over here. Z will be X minus mu over square root of N. Sigma over the square root of N. That's the only difference. So, for example, let's see, we got them right here. Shoes. There's a bunch of shoes. We know, there's no doubt about it. There's shoes in a shoe store. Then the mean is 75 bucks. And the standard deviation, I think, was 27, 27 bucks. We know that for a fact. That's from, that's been since the shoe store opened in, like, I don't know, the last 20 years or something. And so then we're just going to take a sample of 100. So we pick 100 shoes. And so all we're going to do now is ask normal curve probability questions about these 100 shoes. What is the probability that the mean for these 100 shoes is greater than something, is greater than $81? That's all we're saying. So here we go. Z is X minus the mean over the standard deviation divided by the square root of N, which is 81 bucks. This first one is 81. 81 bucks minus 75 bucks divided by 27 square root of 100. This can become a calculator difficulty. The square root of 100, fortunately, is 10. The whole thing here, I think, is 2.22. If you do all the arithmetic on your calculator correctly, you'll get a Z value of 2.22. So what does that mean? Here is the mean, 75 bucks. Here is 81. And we want to know what the probability is. It's greater than 81, so we're looking that up. And so if you look it up, 9686. Yeah, that's what I looked up when I looked up 2.22, 0.9686. However, that's this part, not that part. So we're going to take 1 minus that, 3% somewhere. 3.14. 3.14%. Let's go over here and just write a sentence. Where are we? Let's go over here and write a sentence and stop. Of the 100 shoes sampled. The probability that their mean price is over $81, more than $81 is 3.14%. I'm going to make a homework assignment here. I wanted to do another example. Homework, page 310, evens, 310, 12, 14, 16. Well, it's actually 311, I think. 12, 14, 16. Good luck. Hopefully that was helpful.